50, 50. Pretty good. What's that? All right. G period, calculus A, B. What's the date? September 23rd. All right, sweet. All right, so we got attendance in. All right, let's pray. All right. Okay, in the name of the Father, and the Son, and the Holy Spirit. Amen. Hail Mary, full of grace, the Lord is with thee. Blessed art thou among women, and blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners now and at the hour of our death. Amen. In the name of the Father, and the Son, and the Holy Spirit. Amen. All right, any questions from the homework? 5. Okay, we'll do 5.
It's kind of like a general question.
Yeah.
So, you put like the D and over the DX.
Yeah.
Why can't you like take out the
Yeah, so that's a really good question. Yeah. So f of t, that's at t squared sine t. So number 5, we're looking at number 5 from the homework.
Yeah.
Okay, so this f of t equals t squared sine t. They ask you to take the derivative of it. Find the derivative.
Question.
How we doing?
Did I leave my iPad?
Yeah, it's on my desk.
Thank you.
Yeah. All right, t squared sine t, right? So they want us to find f prime of t. They want us to find f prime of t. Are we following that so far? We're not following? Okay, cool. Okay, so if you tried doing d over dx of t squared sine t, right? That's not quite right. And Dinar is actually on the right track as to why it's not right. Because notice there's no x's in here, right? So if nothing depends on x, because that's my variable of differentiation, right? Then this means take the derivative with respect to x of all this, right? This would be what? It would end up being 0. Because you could pull everything out and then you just have the derivative of 1. You just have the derivative of 1, which is 0, right? That would end up being 0, right? So this is a good distinction to make, right? What they're actually asking you to do when you find f prime of t, so this is like a notation question, is they want you to find d over dt, t of t squared sine t, okay? So this specifies the derivative variable. Yeah, my bad for not making that distinction before. Okay? So yeah, so do you guys see why this notation is a little more precise than just f prime?
Yeah.
Because this actually tells you what variable you're differentiating with respect to. And so in our course, we're only going to see functions of single variables, but in like a college course, you could see like f of x comma y. You can have a function of 2 variables, and if you're going to take the derivative of this with respect, you can't just write prime, because what does that mean? Are we doing x or are we doing y? We don't know. So this is a good habit to get into, to ask yourself, what is my actual variable of that I'm differentiating with respect to? Does that make any sense? Yeah, read.
Were 15 and 6 the same equation?
15 and 6.
Yeah, okay, and on number 9, this might be a pseudo question, but is cosine, prime would be cosine x e to the x.
So first question, yeah, they are. So are those just the same problem?
So can I pull the e of x out like that, or is that not
At the beginning? Okay. You can't like pull it into the top.
No, right, can I pull it out over like is undistributed or whatever it's called?
Oh yeah, you can factor it.
Okay.
Yeah, you can factor it. Yep. Any other questions? Yeah.
Can you go over 14?
14. All right, 14. So we've got y equals x squared minus k squared all over x squared plus k squared. Okay? What rule are we going to use for this? Quotient rule, okay? So this, we're going to write this as sum, right? F of x over g of x, right? So what's my f of x here? X squared minus k squared. What's my g of x? X squared plus k squared. So then, what's my f prime of x? Are we a little confused on this?
2x.
So it's going to be 2x, just 2x, right? And that's because why? F prime of x is going to be d over dx of x squared minus k squared. Okay? So that's the same thing as d d over dx of x squared minus d over dx of k squared, right? I think we're on the same page. This is 2x. This is what?
1.
So the derivative of k
Zero.
squared, yeah, be 0, right? Because k doesn't actually depend on x at all. So when x changes, k doesn't change at all.
Wait, so how come that one over there would be 1? Oh, you.
Well, it would be, it doesn't end up being 0, yeah. So this goes away, and we're left with just 2x. Okay, so that's my f prime. My f prime is 2x. Okay, and then what's my g prime? It's the same concept. What's g prime? 2x. Yeah, good job. And then how do I plug this in? What do I write? What do I write first? F prime times g. What's my g? It's x squared plus k squared. Minus, then g prime, right? Times f, which is x squared minus k squared. That's all over what, guys? G of x squared, yeah. So x squared plus k squared, and all that is squared, okay? All right, so did anyone simplify this any further? I think you can. So you guys wanna, so here's my actual y prime here. So at this point, all the calculus is done. Now I just gotta do a lot of algebra, right? Because I have to simplify this. So the top, let's distribute. It's gonna be y prime equals, so expand the top, 2x cubed plus 2x k squared. You guys see I just distributed that first term. Let's distribute this. Minus 2x cubed plus 2x k squared. And that's all over x squared plus k. Let's wait to expand that for a little bit. Okay. So these cancel. These combine. So like y prime equals 4xk squared all over x squared plus k squared squared. Okay. You could expand the bottom. I won't take off points for that. But expanding the bottom, it's not going to cancel out with anything in the top. It won't simplify our answer any further. So we're just, you don't have to do that, okay? Don't want to waste too much time on something we don't need to do. Any others? We have time for one more. Yeah, Jack? 19. Determine the points at which the graph of the following function has a horizontal tangent. Horizontal tangent, okay? So what's the derivative function going to equal if my tangent line is horizontal? 0, right? So I write that as what? F prime of x equals 0, right? Okay? Do we know how to take this derivative to get what the derivative function actually is?
Yes.
Okay, what did you guys get for that? What do we get for the derivative function of number 19?
2x times x squared minus 4 minus x squared times 2x, and then x squared minus 4 is in power.
All right, that's a lot. You guys want me to just do that on the board? Find the
Yeah.
derivative function on the board? Okay, let's do that. So the initial function they give me is f of x equals x squared all over x squared minus 4. Okay, so what's my, let's do h of x over g of x. Let's call it h of x over g of x. Are you guys okay with that? What's my h of x here?
X squared.
X squared. What's my g of x?
X squared minus 4.
X squared minus 4. What's my h prime of x? 2x. And what's my g prime of x? 2x, right? So plug it into my quotient rule. Quotient rule, we get h prime times g, h prime times g, so 2x times x squared minus 4 minus hg prime, so x squared times 2x. X squared times 2x, that's 2x cubed, all right? So we're good with that. And that's all over what? What's my g?
X squared minus
x squared minus 4 squared. Okay. Let's simplify, so I'll distribute to the top, 2x cubed minus 8x minus 2x cubed. Okay. And then if we can expand the bottom if we want to, it's not going to take us to the wrong answer, but we don't need to do that. We don't need to do that. So here's my y prime, and I need to set this equal to what? 0, yeah. Because the horizontal tangent line means my tangent line has a slope of 0. Yeah, so I can cancel out the 2x cubes. Okay, so I have y prime equals negative 8x over x squared minus 4 quantity squared. Okay, now I'm done with my calculus. Now how do I find all the x's that make this function equal to 0? This is pre-cal review.
Just
Set it to 0.
Yeah, set y equal to 0.
y prime. Y.
Y prime, yeah, so if it's set equal to 0, what has to be 0 here then? The bottom or the top? Top, yeah. So when the top is equal to 0, my whole function y prime will equal 0, right? So then, yeah, so we solve for x here. We get x equals 0, okay? X equals 0. So we know that at x equals 0, my original function, this is number 19, was it?
Yeah.
My original function will have a horizontal tangent line once it's out, okay? One more thing. You have a question with what we do,
Yes.
what we just did? Okay, yeah.
If we get x equals 0 up top, what would happen if we had, like say you got rid of the negative 4 and it was just x squared? Would that also not work because it would be 0 over 0? Like what if it was an undefined?
Yeah, that wouldn't,
What would happen if it was like that?
then we would have no points
Okay.
with a horizontal tangent line. Yeah. So then going back to this problem, okay? So we got x equals 0. Let's read the directions carefully. What do the directions say? Let's look. Determine the points, right? Do I have a point here, or do I just have x equals 0? That's not a point, right? So how do I get the y coordinate? Plug in 0 to what? The original function, yeah. The original function. So that'll give me f of 0 equals 0 squared over 0 squared minus 4, which equals 0 over negative 4, which equals 0, okay? So my point is what? 0 comma 0, yep. All right, we okay with that? All right, you guys okay if we go ahead and pass those up? Thank you. So I'm thinking we're going to finish the Unit 2 notes today. Finish the Unit 2 notes.
Yeah.
Get on with our lives. Get on with our lives. Yeah, and I'll pass out the homework for Monday. Yeah. Wouldn't be math class without homework. All right. Screen here. Let's get our Unit 2 notes packet out. Get our Unit 2 notes packet out. Oh no, I mirrored to the wrong TV. Sorry, Mr. Meyer. Yeah, what's up?
Can I even have a pink sheet?
You want another pink sheet?
Yeah, I wanna kind of use this.
Yeah,
It's so like, I feel like I don't have any more space.
okay, yeah, do you want it right now, or can we get it in the class?
I can get it in the class.
Yeah, so there's more in my room we can get after class. So with the Unit 2 notes pulled up. Okay. Alright, so we ended. Did you guys get this on your pink sheets? It's in the box here. Alright, so make sure this is on our pink sheets. We're going to talk about the derivatives of tangent, cotangent, secant, and cosecant. Cosecant. Okay. Alright, we need some water. Alright. Alright, so we're going to start off with showing you guys why this is true. I'm going to prove why this is true. Why the derivative of tangent x with respect to x equals secant squared of x. We started doing this on, when I last saw you guys Wednesday, right? Remember at the end of class?
Oh, yeah.
So
Yeah.
I was trying to figure it out.
Mm-hmm. You figured it out.
No, they do it a different way here. You don't use the limit definition. So what they do is we want to find the derivative of tangent x, right? Right, so one way we could do this, right, we could do the limit definition, so that would be limit as h goes to 0 of tangent x plus h minus tangent of x all over h as h goes to 0, right? That's the limit definition of the derivative, okay? We could do it that way. Does anyone know an easier way we can do this? Anyone think of an easier way, an easier method?
Quotient?
Yeah, quotient rule, right? How can you use the quotient rule? There's no...
Because tan x equals sine x over cosine.
Yeah, so this is the derivative of tangent x is the same thing as d over dx of sine x over cosine x. So hopefully from pre-calculus or the review packet here that we've given out, hopefully you remember that tangent is equal to sine over cosine. Okay, so instead of doing the limit definition, right, we have all the tools to just do this derivative directly, don't we? We don't have to go the whole like limit definition route, so let's get rid of this. This is hard, this is tough. All right, yeah. Okay, so then what's my f of x gonna be? Sine x, right? What's my g of x? Cosine of x. My f prime is what? Pink sheet, this is on the pink sheet. Cosine of x. What's my g prime gonna be? Negative sine x. Yeah, negative sine x, okay? Quotient rule, right? So it's gonna be f prime times g, so cosine squared of x minus f times g prime. So that's gonna be minus a positive times a negative, so it's gonna be plus a positive, right? Yeah, it's gonna be plus sine squared x. Right, and that's all over what?
Cosine squared.
Cosine squared.
Wait, what?
Confused, I know.
No. How is sine positive?
So I'm doing minus, so this is minus. My second term here is negative sine x times negative sine x, okay? See this is a minus,
Oh,
yeah. So the two negative signs cancel each other out, so it becomes a positive. Okay, what's the top here equal to? 1, yeah. What's the bottom equal to? It's still cosine squared of x. And then what's 1 over cosine squared? Secant squared, yep. So pretty straightforward there. We use our new derivative tools that we learned, okay? So that's why we do that. Okay. All right. Why don't we try example 1 on our own? So A and B, we should hopefully be able to do those on our own, right? You got to use what we just talked about up here in the box. All right. So look at your pink sheet. Look at these 4 on your pink sheet, and use these to do A and B from example 1. Okay. Let's try that out.
Just want you to know that I remember the cosine squared x was 1. Thank you. 40 years ago.
That's good. Yeah, they tell you you're supposed to burn that. Keep the using pre-cal.
He's dead.
Get burned. Get a tattoo of cosine squared plus sine squared equals 1. Yeah. Whatever it took. minus sign in between them, so you just split it up like that. For this one, we're going. This one, right, there's a multiplication sign, so use the product rule, right? That's a product, this is a difference, so you just get it there. All right, hopefully we get on the first one. All right, so y prime is going to be, oh, let me use a thicker pencil. So y prime is going to be d dx of x minus tangent x. What do I do when I have the derivative of a difference? Split it up, right? Yeah, so it's going to be d dx of just x by itself minus d dx of tangent x, right? What's the derivative of x? We use what? Yeah, that comes from the power rule, right? What's the derivative of tangent x? It's on the board. Yep, secant squared. Yep, secant squared of x. Good job. That's my y prime. Is there a trig identity that we can rewrite this with?
Is it tangent?
1 minus secant squared. Let me just look this one up. Look that one up real quick. I gotta print out some. I gotta print out like a trig identities sheet.
Wait, you don't have it? Yes.
All right, so there's 1 secant squared minus tan squared equals 1. So there's a trig identity that's secant squared of x minus tangent squared of x equals 1. Okay, so we want 1 minus secant squared. So if I add tangent over here, I get secant squared x equals 1 plus tangent squared of x. And if I subtract 1 from both sides, I get secant squared of x minus 1 equals tangent squared of x. So this becomes tangent squared. Oh, negative tangent squared, you're right. Thank you. Yep, so there's my final answer. Let me use a different color highlighter.
Did you leave it as 1 minus secant with x?
I might take off just like a little bit for not simplifying it all the way.
Really?
Yeah. So let's get familiar with our trig identities, okay?
You have a sheet with your trade and then he's on like,
Yeah, I'll get one out for you guys. Yeah, I think that's on the next part of the review packet. Let's do October 3rd. All right. Okay, part B. Are you okay if I move on from this one? Okay, so here we go. What are we going to use here? Product rule, right? So this is 2 functions multiplied together, right? So what's my f of x? What's my g of x? Secant of x, yeah. Secant of x, okay? So f prime is what? 1. What's g prime? Secant tangent, yep. Okay, so this is going to be f prime times g, so what's that? Secant x plus f times g prime, which is x secant x tangent x. Okay. Right, I can factor out a secant, so I've got a secant here and a secant here, so I can factor that out. I think that's all the way simplified, right? I don't think there's any more trig identities we can use for that one, yeah? So here's our final answer. How are we feeling about that? Feeling okay?
For secant x, tangent x, I like distributed the x.
So, let me see. Yeah, so you can't distribute anything here. So secant x, this does not mean secant times x. That's like an x that's plugged into another function almost. So let me put parentheses here. You can't move. So algebraically, your x right here, you can't move this into here. Can't do that. You just gotta leave leave it on the out. You can't move anything inside or outside of these parentheses when it's plugged into a trig function. Does that make any sense? Okay. Yeah. And you also don't need to distribute because there's not a plus sign here. So this is one term. This is one term. You only distribute when you're multiplying like multiple terms by something. Does that make any sense? Okay. Okay. All right. How are we feeling about that one? Feeling okay? All right. Let's keep going through these Pythagorean trigonometric identities. Yeah. So we wrote. There's two of them right here on this board, right? Cosine squared plus sine squared. This is probably a pink sheet too. Cosine squared plus sine squared equals 1, right? We wrote secant minus tangent equals 1. And then that third one, I think that's it. It'll be cosecant minus cotangent squared equals 1. Alright, so these are pink sheets. We're just doing unit 2 notes. Alright, let's get those written down. Okay. Alright, okay, if I move on, I'll just zoom out. Alright, so activity right here. Alright. Alright, so some of us are going to take the derivative of this left side. Some of us are going to take the derivative of the right side. Okay. So Tyler, why don't you do the left side, do the right side, right side, Campbell. Left side, Jack. Right side, Nick. Left side, Dinara. Right side, Mayana. Left side, Rook. Take the derivative. Let's see. Yeah, so you're going to use what's in here. Have we done product rule yet? Yeah. Okay, yeah, so you're going to use, did I say the left side or the right side? Do the right side. Yeah. If you have no quotient rule.
This way.
Yeah, so you just got to use, there's 4. If you flip that packet over, use these 4. So pink sheet those.
Yeah.
Get those on your pink sheet, and then you'll be able to do it.
Yeah.
Erase the board while you guys are working on that. Good. Do some gum on this. Is that? Yeah. You're fine. You're fine. about subscribers, like 10 probably. I think I may have like one.
Should I bring my 150?
I have one sub for next week, Mr. Chapman.
Yay.
Where do
What day?
Tuesday, Friday, Monday. No, Thursday, Friday, Monday, Tuesday, Wednesday.
Why?
Wait, what?
Okay.
Mom's getting back surgery.
Oh, yeah.
Your mom's getting back surgery?
Yeah.
Why would her back?
She has degenerative disc disease.
Oh.
That's like the discs are like calcified.
Oh.
Is there a project on that one day?
How do you say that? You're smiling.
What can I do about it?
He always smiles.
Stop being degenerative.
Mr. Rushton never mad.
Oh yeah, never.
I don't want to look at
I just repress all my feelings. It's cheaper than therapy.
That's healthy.
Not healthy, but it's cheap, so.
Yeah, that's true.
Alright, we still working? Anyone still working? That one on the left is a little, a bit of a doozy. If I would have won the rock, paper, scissors, I would have chosen the right. So, this is saying your pink sheet, okay. So, you're gonna take the derivative of the first one, and then it's gonna be minus the derivative of the second one. Okay, so hopefully you remember that. We haven't been doing that while you were here.
I got one. I did the
So
one.
if you do cosine, it's gonna be minus, this becomes minus derivative, you take the derivative. This becomes minus cosine of cotangent x.
I'm so happy about that.
Alright, so let's do the left side here. The left side takes a little longer, right? What's the left side? So this is going to be, what we're doing here is d over dx of all this stuff in the brackets equals d over d of x of all this stuff in brackets. So we see that? So we're taking the derivative of both sides. That first side, right, I'm going to use what? Quotient rule, okay? What's my f of x? 1 minus cosine x. What's my g of x? Sine of x. So f prime of x is what? Sine of x. G prime of x is what? Okay, so quotient rule f prime times g, so that's sine squared of x, minus g prime times f, so it's going to be cosine x times 1 minus cosine x, all over what? Sine squared of x, okay? Alright, you guys want to simplify this one a little bit? Let's distribute my cosines. So I'm going to get sine squared minus cosine x plus cosine squared of x, right? Did I do that wrong? Okay. And that's all over sine squared. What happens to my sine squared and cosine squared? They become 1, right? So this sine squared and this cosine squared here, they add together to give me 1. So I'm going to have 1 minus cosine x all over sine squared of x. No? Okay. Right side. What do this one's easier, right? I don't have to use the quotient rule, so this becomes d over dx of cosecant x. That's terrible handwriting, sorry. That's better. Minus the derivative of cotangent. Okay, what's the derivative from our pink sheet? What's the derivative of cosecant? What's the derivative of cotangent? That's going to be what? Minus cosecant squared? Okay, so I'm doing minus cosecant squared. So it's going to be what? Plus cosecant squared of x. Okay? And then, okay, does that look like the left side? It doesn't, but could it? We gotta do just a little bit of trig identities thing. Okay, so this is what? This is gonna be, how do we wanna do this? This is gonna be minus, what's cosecant? 1 over sine times cotangent is what? Cosine x over sine x plus 1 over sine squared of x. Okay, these first two are going to combine to give me negative cosine x over sine squared of x plus 1 over sine squared of x. And you see how I have common denominators here, so I can just combine these. Gives me 1 minus cosine x all over sine squared of x. Are these the same now? Yes. Yes. They are the same function. Okay? How are we feeling about that? I guess, how are we feeling about that in terms of, like, do we understand the math? And then how are we feeling about that in terms of, like, unpacking feelings about it? I don't have too many feelings about this. This doesn't really come up for me. Okay, are we done with the packet? Yeah, we're done with the notes packet.
Wait, I have a question.
Yeah.
So where are you getting this square, like sine squared x? Like, how are you getting that?
So I do f prime times g. This first term is f prime times g. F prime of x is sine x, and g of x is sine x. So then f prime times g will be sine times sine, which is
Wait, f prime times what?
f prime times g.
I don't know.
We didn't go over quotient.
No, I haven't done it.
Yeah.
Yeah, that's what I meant.
All right, and then we'll just work on the homework for the rest of the time, okay?
Is there like videos on this or no?
No, yeah. So I'm trying to get that figured out. Right now I'm using my phone, but
Like, how should I get these nuts? Like,
How
how
does
should
Mrs. Ford do it?
what's that?
How does Mrs. Ford do it?
She doesn't use her iPad. She uses the whiteboard. Right, she uses her whiteboard to like write the notes down.
Yeah.
But when I do that, it just looks terrible. So I'm just not as good. Don't have fine motor skills. So I'm using my iPad to lecture, so I don't have anything to record. I have my computer, but it like dies every 3 minutes. So
Oh, so she records with her iPad?
she records with her iPad, yeah, and it works out great for her because she's really good at using the whiteboard. But that's not as good for me because my handwriting's not as good. So there you go. I am your thing.
Look at this. This is
I have this one.
Did you get the homework from last time?
And then look at the spring on the inside.
How was your college visit?
That is good.
Good. Where'd you visit?
Duke, UNC,
Duke?
Wake.
It's supposed to have a
Good.
laser.
Are you gonna apply those places?
Yeah,
Good.
I mean, we're starting to oxidize
yeah,
too.
I like it.
That's cool. Yeah, I would like to visit. That'd be funny if I like ended up at the same school as someone.
Yeah, that would be, yeah.
I don't want to take that part.
All right.
So where should I get these?
Georgetown, right?
Yeah.
As long as I get my styles, you can do whatever you want.
Can I just give you the notes?
Yeah.
Anyone have like, I'm sure you like Russia has flyers. Mr. Rush, could you get flyers?
No.
Never mind.
I should get some though.
You should. You need like.
You need a whole group.
Yes.
So you were gone. How many days? Last 2 days?
Yeah, this is the last one.
That's Luke. Luke's
I got
got
it,
spots
I got
right
it.
there.
Oh, that's weird. It smells so bad. Yeah. So yeah, the battery, like, either.
So you did do 16.
Or-
Did you do like a table problem?
I think
No.
that's what's causing it to come apart like that.
I did feel like it was
I'll walk you through. I can help you through those. All right. So I'm just gonna stop the video then. Sorry.